Hello, everybody. We're going to get started in just a minute or two. We're getting everybody into the webinar right now, so just be patient and we'll get started in just a minute. If you're having any problems, just use the chat box. Tell us what your problem is and we will help you get that addressed. All right, we're going to go ahead and get started. Good afternoon, everyone, and thank you for joining us. My name is Chris Bonamy. I am the Deputy Director for the DuPage County Stormwater Management Department, and we are here for a water quality outreach webinar that will cover a non-point source phosphorus reduction study that was led by the DuPage River Salt Creek Workgroup. Phosphorus can reach waterways through multiple sources, notably through leaf and lawn litter carried by stormwater runoff over impervious surfaces. This fast-moving runoff doesn't allow for infiltration or pollutant removal, but multiple studies have indicated that a common practice of street sweeping can capture these pollutants before they become an issue. So that's kind of what we're going to be covering with the webinar today. This is a free webinar, and one PDH, one professional development hour, will be made available. We have several of these workshops throughout the year. We find they are a great way to connect like-minded individuals and organizations who are concerned with the water quality in DuPage County's lakes, rivers, and streams. These workshops are part of our public outreach and education programs and help us meet requirements outlined in our permit with the Illinois Environmental Protection Agency. The webinar is being recorded, so if you know of others that can't be with us today who might benefit from this information, we will provide a link to the recorded presentation shortly following our webinar. Before we begin, just a couple thank yous. Thank you to Mary Mitros. She is the Stormwater Communications Supervisor, and she is behind the scenes running our show today. Thanks to the Conservation Foundation. They are our partners for all of these workshops and webinars, specifically Jan Rail. She is the DuPage County Program Director for the Foundation, and she helps line up our speakers for our programs here. And speaking of our speaker, thank you to Stephen McCracken from the, also from the Conservation Foundation, as well as from the DuPage River Salt Creek Workgroup. And we'll hear from Stephen in just a couple minutes. And then finally, again, I'd like to thank all of you for joining us this afternoon. Just a couple other remarks before we begin. I am excited about the topic of our webinar today because improving water quality is one of the main objectives for our stormwater management department. A great way to reach those objectives is to set goals. And one of our goals for better water quality is, of course, to reduce the amount of phosphorus from reaching our waterways. So this webinar fits perfectly with that goal and objective. And kind of on a personal note here, I also like to set personal goals throughout the year. I find that it's a great way to stay motivated and focused as you try to reach whatever milestone that you are trying to attain. Just as an example, I set a goal earlier this month, actually, I guess it was March 1st, just 10 days ago, to actually lose 10 pounds before the end of the month. 10 pounds doesn't sound that drastic or unattainable, and so far so good. I am happy to report that I've only got about 15 pounds to go. Not too shabby. I know that's not exactly weight loss, but setting goals makes me feel better about myself. And what I really feel good about is the speaker and presentation that we have for you today regarding phosphorus reduction. But before I turn things over to Stephen, I do want to remind everybody that you are muted. If you do have comments or questions, please type those directly into the chat box and we will relay those on to Stephen at the end of the presentation. Also, you guys are in charge of your own video cameras. Whether you want those on or off is completely up to you. All right, so let me introduce Stephen. Stephen works for the Conservation Foundation and is the director of DuPage River Salt Creek Workgroup. He is a graduate of Queen's University in Belfast with a degree in geoscience. He holds 2 master's degrees, one in water resources from the University College of North Wales, and the other in applied environmental economics from Imperial College in London. He has 27 years of project management experience gained working in Europe, Africa, and North America, and he has authored several papers on resource management and water pollution. In addition to his job, Stephen serves as the Illinois Water Environment Federation Watershed Management Committee and is a regular contributor to the organization's newsletter. He is also a member of Burr Ridge's Environmental Quality Committee. So with that, Mary, please turn things over to Stephen so he can begin his presentation.
Okay, Mary, I'm good to go.
Yep, we can hear you. We see your slides. Yep, you're
excellent.
Good.
That's a good start. Well, thank you very much to Stormwater Management for inviting me to speak on this subject today, and also for all of their help in getting this study going and all of the great work they do in helping with water quality around the county. The study I'm going to be talking about today is part of a larger study, which I'll also talk briefly about, and it is the phosphorus non-point source feasibility analysis. Hold on, it's not advancing. I'm going to stop sharing for a second and reload it, okay? Oh, there we go. Okay, so before moving into that, just like to say thank you to all the members of the DuPage River Salt Creek Workgroup. Of course, it made up of MPDS permit holders throughout areas of Cook County, Will County, and of course, DuPage County. This particular study is funded by wastewater treatment plant members as part of an agreement with the US and Illinois EPAs to allow them to trade off removal of phosphorus in their wastewater for implementation of a local watershed plan. And as part of that, they have to develop a study looking at nutrients, and that's what we're going to talk about today. Mary, I noticed that it's advancing without my telling it to, so I may be jumping back a little bit back and forth. I don't know if it's on some sort of setting.
No,
okay,
I'm not sure. If you want to reshare it, go for it. I'm not doing anything, so.
Okay, yeah, well, we'll continue like this, and if it does it again, it's not too difficult. It allows me to go back at least. So quick agenda of what we'll be talking about. I'm going to look at the context that this study was created in, and then we're going to look at this thing called the NIP, which is this nutrient implementation plan, as well as the objectives of this particular part of that plan. We'll look at the methods, GIS, analysis, and the results of the study, as well as the recommendations to come out of it. And I'm going to try to put those recommendations into context of the larger phosphorus control framework that will be developed over the next few years. Okay, so what is a nutrient implementation plan, and why would someone want one of these? Well, it really wasn't a choice. This was it's a mandate from the state of Illinois to everyone holding a wastewater MPDS permit. They were told that they were to get into groups and they were to develop this plan. And what the plan is based around is that if the waterway you're discharging to is impaired, that's fancy speak for it's failing to meet the state thresholds for dissolved oxygen, and if it had these offensive conditions. And offensive conditions is basically if you've got out of control algal or aquatic plant growth, more than what the state judges the waterway should have. And sometimes that is a symptom caused by excessive phosphorus. Such waterways are often placed on a list where they're failing to meet state threshold. This is through a 3D list that the state publishes every 2 to 4 years. Needless to say, the DuPage River and Salt Creek, where this study was carried out, are very popular on that particular list. So the nutrient implementation plan sets out that you have to look at point sources of phosphorus, non-point sources of phosphorus, potential other sources, and all with the goal of removing these offensive conditions for algae or for dissolved oxygen. Critically, the nutrient implementation plan is also to include a schedule for implementation, saying that these are the remediative actions that we will take, and this is the time that we will take them in. They'll be completed or largely in place by this date. We are working with a group called the Lower DuPage River Water Coalition. They're a similar group to the DRSCW, but work on the main stem of the DuPage River in Will County. It just made a lot of sense to work together as we're all discharging to the same waterway and produce a single NIP to cover that entire watershed for DuPage. This final report has to be with the state of Illinois by 2023. I would advise that we are not envisaging this as being a complete report at that point. It'll rather set out what we think needs to be done in order to move the indicator closer to where we think it should go. I think it would be hubris to think that we could foresee every eventuality and every cost to do with removal of phosphorus by 2023. Some of these actions have to be taken in order to judge what additional actions would have to be taken in order to hit the goals. So the NIP itself then sets out that we have to look at majors and minors. These are various classifications of wastewater treatment plant size, MS4 communities, obviously, industrial stormwater permittees, and then perhaps other non-point sources. The DRSCW, along with partners, notably, of course, County Stormwater and other agencies, doing a lot of in-stream monitoring. So a lot of if I'm showing stream level data or something to back up some of the conclusions that we come to at some point, that is all being collected locally in order to support the analysis and also to try to look forward to see what we need to do. So moving back to the non-point source feasibility study. This set out to look at to try to evaluate the impact of current area street sweeping and leaf litter management practices on the amount of total phosphorus that is making it into our waterways. And then perhaps out of that, also look at some ways that perhaps these programs could be made more effective in terms of total phosphorus capture. So why did we start looking at street sweeping and leaf litter management as opposed to the other options for dealing with phosphorus in urban stormwater wash-off? Well, we've been looking at this for a while, and one of the things that we did was that we helped fund a study up in Wisconsin, which was done by this gentleman, Bill Silbig of USGS, and I believe he's actually talked at several of the events down here in DuPage County about this study, so I'm not going to go through it in a lot of detail. But basically what his analysis found was that a very large amount of the total phosphorus wash off annually was found in the months of October and November. And we'll look at what his study shows. This is one of Bill's slides. We obviously, as a funder of this, he has allowed us to use his slides in our presentations. What you can see here is this is obviously an annual sampling of phosphorus runoff from 2 catchment basins. And you can see that, when we move into September, we see this very large jump in phosphorus at both of the sample sites. So few things to call out here. That bump represents 60% of the total phosphorus that was encountered running out of the two catchments in over the course of a year. I would also direct your attention to the smaller bump in May. It's much smaller, but just due to the way that phosphorus interacts in our waterways, that little bump there should not be forgotten. I guess what I'm saying is just due to the fact that we often encounter algal and dissolved oxygen problems in the waterway, it may be that a pound of phosphorus in May is more important than a pound of phosphorus in, say, October in terms of getting into a river. Perhaps not a lake, but in a river system where we'd expect in October that it would go into the river and it would have exited the basin come the following year. So I don't want to, I'll be talking mainly about the September, October period, but I think we need to keep that May in the back of our minds. So the second thing that this study then set out to do was, okay, it looks like this bump in phosphorus is coming from leaf litter debris. Can we prove that? And is there a way we can do to prove it that would also point the way to perhaps if a managerial regime could change it? By managerial regime, I simply mean if we were to go out and pick up all of the leaves, would we be able to flatten that spike? So in fact, that is what they did. And over the sort of baseline condition, they were able to reduce the loading by, I think it was like, they were able to reduce it by over 60%, if I remember correctly. So this is a great finding in two ways. First of all, it did show that it was leaf litter debris that was in fact driving up these phosphorus concentrations in the stormwater. And the second thing was that it was amenable to that if we did remove the leaves, then in fact we were able to sort of remove this spike. And in doing so, remove 60% of the phosphorus running off in stormwater over the course of a year. Now, I should point out that the USGS experiment was they were very thorough with their leaf removal. It was a level of leaf removal that is beyond any sort of standardized annual operation. But they did that on purpose because, if they were unable to flatten this spike by doing an operation like that, that would suggest that this kind of managerial system, through street sweeping, leaf litter pickup, etc., was not going to be successful. However, it was successful, but we should expect that any managerial recommendations that we would make would probably have a lesser impact by how much we don't know. We don't know how linear the relationship of phosphorus removal is to sort of the allocation of effort here. So there were another couple of reasons why we were interested in street sweeping and leaf litter pickup. We knew that if we were to put any recommendations into this nutrient implementation plan, the state and federal government do have a way of turning that around and then placing it in people's permits. So we wanted to be cautious that we were recommending something that agencies were already doing, and that what we were looking at, instead of increasing resources put towards that effort, would perhaps lean more towards the allocation of effort through time and space. In other words, was there perhaps parts of the watershed that should be vacuumed and more regularly, or if there were times of the year when perhaps we should do more street sweeping and reduce it in other parts of the year. We also wanted to make sure that agencies that were already doing this and capturing phosphorus were in the position that they could receive some credit for doing that. In other words, that it wasn't that agencies were just doing nothing. They were already, in fact, implementing practices that were capturing phosphorus in stormwater. The other attraction of street sweeping and leaf litter pickup, of course, is that they don't compete with utilities in our right-of-ways. So these right-of-ways are already filled up with a lot of utilities. If we go putting a lot of infiltration BMPs, et cetera, in there, it gets more and more crowded, and it's just harder and harder and more expensive to do. So while those structural BMPs certainly do have a role to play in this, the application across the whole watershed is a much more involved process and a much more targeted process. Street sweeping, on the other hand, is something that can be uniformly applied across the entire area of the program. So the bottom two bullets I've already addressed, that we were directly going after this huge spike that we see at the end of the year in phosphorus. So physically, we were capturing this phosphorus and it wasn't getting out into the environment. The other thing that shouldn't be ignored is that all phosphorus is not equal. So we often measure, and the graphics we saw earlier are all in total phosphorus, but phosphorus can be broken down a number of ways. Most popularly, we break it down, it's not entirely accurate, but we break it down into dissolved phosphorus and particulate phosphorus. So a lot of our infiltration type BMPs, et cetera, are particularly good at capturing that particulate phosphorus, but are not so good at capturing the dissolved phosphorus. And it turns out that the majority of the phosphorus that we're seeing in that spike is in fact dissolved phosphorus. It was about 58% of it. Now that dissolved phosphorus is much more available for algae in waterways to take up. It's readily available to them, much more so than the particulate phosphorus. So it's once again, if we were to weight phosphorus in such a way, we'd be more interested in that sort of dissolved fraction. And by capturing these leaves and taking them out of the system, we're removing that dissolved phosphorus as well as the particulate. Okay, so the survey area, as I mentioned earlier, are these 4 watersheds. So you can see the lower DuPage there at the bottom of this map, and then the west branch and east branch of the DuPage River, which feed into it. So that is 3 basins. Of course, you could also treat it as one single basin. And then off to the right of those 2, which would be the east of our map there, we have Salt Creek. Obviously, a lot of these, especially the 2 upper branches of the DuPage River and Salt Creek, quite homogeneous in terms of land use and practices. This is a large area, 530 square miles, approximately 104 communities, and based on GIS analysis, it's about 8.8 square miles of right-of-way. So in terms of getting this data into collecting it in from the local communities and running it, an analysis on it, we pursued this in a few ways. The first one was we did a literature review of street sweeping, leaf litter pickups, and what the various impacts on phosphorus were predicted to be. This is available. The report is online at our website. I will actually supply that to Mary after the presentation, along with the updated presentation. You can send it out, and we cover the literature review in there, and it does read a lot of interesting points in there about the evolution of how we both monitor for phosphorus and also about the various impacts of these various street sweeping kinds of interventions. A few things worth mentioning was that the street sweeping was found to be, initially it was thought to be relatively ineffective because it wasn't picking up these very fine materials. These are the sort of the sub 45 micron particles. But when it comes to leaf litter, they're actually very effective at picking that up. And because we know that leaf litter is relatively rich in phosphorus, it actually turned that initial assumption on its head. So these are coarse, leaf would be coarse particles, well picked up by street sweeping, and of course containing these phosphorus, which once again reinforced the idea that leaf litter pickup, especially via street sweeping, could be very effective in reducing phosphorus. We also did a GIS analysis to back up this analysis, and very glad that we did, as that become an integral part of how to of understanding and just getting this survey to be as accurate as it could be. And we finally employed this Minnesotan Pollution Control Agency street sweeping tool. This was not a tool that we were familiar with. It had basically come online while we were working on this study, and we had planned on making a much more basic spreadsheet tool to estimate capture rates. And this tool had a lot of background calibration and everything in it that we were able to make use of to make a more accurate prediction. So the first step then was development of this area questionnaire to look at what local practices were. This is based on a Wisconsin MS4 leaf management survey, once again supplied to us by USGS. It went out to 75 DRCW members and also to a number of the lower DuPage communities. Total of 95 entities received it. We received a total feedback from 48 of them, which comprises 77% of the total watershed area. So while we got about half of the answers back, we did manage to get the majority of the watershed covered. The questionnaire itself covers street sweeping. It covers leaf litter pickup and also catch basin management. We haven't really dug into the catch basin information yet, but the street sweeping and leaf litter pickup information were used extensively in this study. Also like to thank DuPage County with helping us get this questionnaire out and chase down people to get the information back in. These studies are always only as good as the information that we put into it. So we really appreciate everybody filling that out and getting it back to us. So then the second part was this development of this GIS map. And this was developed because the literature review had pointed to a number of items, including that canopy cover of roads and right-of-ways was a very strong predictor about how much phosphorus was going to be in street sweeping debris from a community. So what we did was we produced a right-of-way map and overlaid it with a very high-resolution canopy layer, and you can see an example of this map here on the left. It's quite artful, I think, and looking at seeing if I can convince my wife to put it up on the wall. This high canopy or very high resolution canopy layer was a real find. It was developed by the spatial department at the University of Vermont in a project in conjunction with the Morton Arboretum. So we were able to take this, clip it to our project area, and then it essentially had the resolution of showing individual canopies. What we did then was we overlay that onto a right-of-way map, and we clipped that so it gave us the canopy layer that was overleaning the right-of-way, and that essentially was a proxy for how much leaf litter we could expect to end up on a given road. We call this effective canopy cover as opposed to canopy cover, and of course this is all of the reports that we looked at in literature review suggested this was the primary indicator of the concentration of phosphorus in street sweepings, and that being a positive relationship. The higher the effective canopy layer, or percentage, then the higher the phosphorus concentrations would be in street sweeping debris. The other thing we did was that we coded the right-of-way for land use. I believe we used the CMAP 2016 land use data, and we coded those rights of way because it was clear to us that some of the street sweeping varied by land use type, with street sweepings in some areas being more frequent than others. And also some of the literature reviews suggested that there may be some other variation in there. So we wanted to control for that. So we generated this map, which allowed us to look at effective canopy cover within each municipality, essentially, or permit holder, but also then down to the level of what was it like inside each one of the land use categories inside that entity. The map here, as it says at the bottom, is for the city of Naperville, but we do have it for all of DuPage and the area of Cook and Will County that the program covered. So then the next step was to take the data we had on street sweeping and plug it into this Minnesotan Pollution Control Agency street sweeping tool. Now, this is where our first problem was encountered. As you can see here, it is broken into 3 columns. So you have 3 potential inputs: dry mass, wet mass, and curb miles. We were going with curb miles because that is all the data that we had. When we plugged it in, we got a horrifyingly low removal of phosphorus. I mean, to the point that it was ridiculous. And I went back through the model to check that we hadn't misplaced a decimal point by 2 to 3 significant figures. Everything seemed to be entered accurately. So we actually went to the company Tetra Tech, who had developed this tool, and asked them what we were doing wrong. And essentially they told us that option 3, curb miles, was set to a completely unrealistic removal rate. And this was done on purpose under the auspices of US EPA and the Minnesota Pollution Control Agency, because the curb mile to phosphorus remove relationship was the least predictive of the of all of the options. In other words, we could better predict how much phosphorus you were capturing if you had the wet mass data and the dry mass data. Now, this tool was developed for a street sweeping credit. So you can get credits on your MPDS permit in Minnesota if you are street sweeping, and you can put it into this calculator. But to do that, you have to be collecting the wet mass data or the dry mass data. Fortunately, we did not have either of these, so we were stuck with this very, very low figure. We looked it over with Tetra Tech and came up with the suggestion that we could actually tighten up this relationship considerably, because one of the background input files here was a range of canopy layer data, which was quite wide. But we were able to narrow that down considerably because we had effective canopy data for our entire program area. So we were able to recalibrate the tool and get a much more accurate output from the curb miles than the tool in its initial setup would allow. So we changed those input files, and that allowed the tool then to calculate phosphorus capture rates from each of the questionnaire responses. And we compared that to the literature, and it was now matching what the literature was suggesting we should be seeing under similar circumstances. This was not the original way we envisaged using that effective canopy cover data, but it ended up being glad we had it, didn't have to develop it again at this point. So here is a map of the practices. These are the questionnaire responses placed onto a map. You can see the outline of the program area, and I'm just moving to my notes here, make sure I get these right, but these are color coded depending on various practices. For example, the solid green ones that you see are communities that bin and bag leaves and then follow it up with street sweeping. The hatched green, which is one of the more common ones on it, are areas that do leaf collection, leaf pickup, but do not directly follow it with street sweeping. And then we have purple, which is no binning or bagging, but leaves go into the street, but then have street sweeping. And then we have the hatched purple, which are leaves in the street, but no follow-up street sweeping. Blue are leaves in the parkway with street sweeping. So there's various iterations and mixes there. And obviously what the literature showed is to capture the most phosphorus is that you do leaf litter pickup followed by street sweeping. That was the one that produced the highest capture rates. The good news was that all 48 communities and 2 of townships had leaf litter collection programs. And that, but 88% of them did not alter leaf collection for rain. Now, why was that important? A lot of what the literature shows and what the study showed is that what we're really trying to do here is we're trying to minimize the contact time of that leaf on the ground when it's subjected to rainfall. So some communities in Minnesota, for example, are tweaking their leaf litter pickup, looking at weather forecasting and capturing leaves prior to rain to stop any of the leachable phosphorus from entering the system. Leaves that are, have been, if they're picked up after they've been rained on, a lot of that phosphorus can already be removed. Oh, and lastly, only 30% of respondees swept streets after leaf litter collection. Just a few other interesting things that came out of the study. On the left hand, it's just a frequency graph showing, when people are street sweeping. Obviously, street sweeping not typically done during winter months, but does start to pick up in February, and then in March we move into sort of the regular schedule, and then goes through and drops off after November. And once again, what this shows is that residential and arterial streets were the ones that received the most sweeping. On the right is our box and whisker plots for frequency of sweeping in residential areas. We focused on residential areas, though we looked at each area for this, but residential areas receive special attention, and we'll look at why that is in just a moment. But you can see here that street sweeping obviously does pick up in the leaf fall months, which is good, of course. So one of the things that we find is that while this system is not optimized for phosphorus capture, it's not too bad either. In other words, it's quite far towards the optimization that we would, if phosphorus capture was our only restraining factor, it's pretty well placed already to do a lot of that capture. So effective canopy cover can be quite informative on this. What the study showed was that 66% of the program area was residential space, and that was also the area that had the highest effective canopy cover. If you look at the bar chart on the right, you'll see that on average 31% canopy cover, or effective canopy cover inside the residential area. That's probably not a surprise to anyone, but from the sort of data management point of view, it was important to know these aspects when you're looking at optimizing something, optimizing, say, phosphorus capture in this particular case. Of the 8.8 square miles of right-of-way that we mentioned earlier, approximately 2 square miles of it was covered by effective canopy cover. Actually, just before leaving that screen, one thing that is interesting to note was that while we had a tighter grouping of effective canopy cover, and the model had for, it had 300 or 400 different communities in there, we obviously had a smaller list and it was a tighter grouping, we still did see a lot of variability in effective canopy cover. So our effective canopy cover, our lowest was 1% in a residential area, but then also went up to 66%. So obviously we're looking at means here, but that variability is obviously something that models tend to, they like to work in clusters of data, but that's something that if you were looking to optimize phosphorus capture in your community, that you would have to take into account in your individual case. Okay, so how much phosphorus did we work out that the area was capturing? And once again, this is based on 77% of the surface area of the program area. We obviously, we don't know what's going on those other communities, and we could increase it somewhat to take care of that. But we're hoping to talk to those other communities this year and perhaps backfill the amount, backfill that data and rerun that part of the model to get what they're capturing and add that to the total. But breaking the data off at the sort of 25th percentile of the range and the 50th percentile, we got between, you can see there, 6,870 to 12,021 for all roads, and the amount of phosphorus that we're currently capturing, and those are pounds, currently capturing with our current level of practices. That comes out to about 127 to 140 pounds per average per agency. Can vary a little bit because of the curb and gutter roads are, as the model showed, are much more productive in terms of phosphorus getting into the environment as compared to all roads. So that moves us to, well, I was going to address this in a few moments, but I may as well take care of it now. It is, say go to 6,000 pounds at the 25th percentile or 12,000 pounds. Is this a lot of phosphorus? So yeah, it is quite a bit of phosphorus, but I think it needs to be put into context. I worked out that for the upper DuPage and Salt Creek treatment plants there, they probably, the 12,000 figure, they probably put that out in about 4 days, based on certain assumptions about, we have data from their incoming you know, what their output of phosphorus is. So, you know, depending on you know, using various kinds of data, you're looking at, you know, something like in the region of 4 to 6 days of treatment plant loadings. So clearly the phosphorus that we're observing in our waterways is nearly entirely coming from wastewater treatment facilities. And that's important. That's what this nutrient implementation plan will be breaking out. But it was important to quantify this so we could accurately prescribe a remedy for the phosphorus levels in our waterways. So recommendations for optimization. So again, a lot of this comes down to is that what we would try to avoid if we were optimizing this is that having leaf litter in the road on the impervious surface getting rained on or driven on. A lot of the studies show that leaf litters it leaches phosphorus much faster when it is being, you know, kind of masticated by vehicle traffic and such. So, you know, that time of it lying in the road pickup and certainly outside of rainfall is a very important factor. So one of the most effective ways from the literature was, of course, increasing street sweeping directly after leaf litter collection. Also increasing a less accurate approach, but still would have impacts, of course, is just increasing street sweeping during leaf collection months. And then one that we didn't control for, but would seem to have an impact would be, of course, also that spring street sweeping. As we remember, if we go back to our USGS graph, we did see a small blip early on in the spring. That phosphorus, again, would take further research to confirm that, but it's quite possible that that phosphorus has a bigger impact per pound on the river than phosphorus that's released later on in the year. You could also prioritize leaf collection and sweeping by effective canopy cover. That's areas where we're likely to have just a higher load of leaves, which will be then available for leaching of phosphorus. Again, this is probably something I think the communities probably do without thinking about phosphorus, simply because they're trying to keep those storm drains open and remove the leaf litter from residential streets, for example. The bottom one, explore landscape ordinance to prohibit blowing of landscape waste into roadways. That's kind of outside of this study, but that is something that we will be mentioning in our nutrient implementation plan. That is simply that leaf litter is obviously not the only organic detritus that can release phosphorus. When we cut grass and blow it into the road, for example, that is also available for leaching off phosphorus, though we need to do a little bit more research to see exactly how much phosphorus is coming out of that. But it is available at peak times of year, spring, right in the middle of summer. Those are the times when algae is most is growing, and so it can make the most use of that phosphorus. So again, it may be, although we're seeing this phosphorus spike in the fall, it may be that at those early releases of phosphorus are more impactful. So opportunities for further study. This year, we're going to try to increase the rate of response to our questionnaire. So we'll be going to those communities and agencies that we didn't get a response from and trying to fill out the rest of the data set. Aim obviously would be try to get 100% response. But we won't be coming back to, I know a lot of folks on the phone already answered this. We won't be coming back to the communities who already answered. We'll simply be going to the ones who didn't answer the first time around. We may try to increase some of the data that we collect in terms of looking at phosphorus speciation. That's what I was talking about, the dissolved fractions of phosphorus and then the particulate fractions of phosphorus. That may be pertinent in trying to fully gauge the impact of stormwater phosphorus runoff. And the other item that potentially interested may be trying to grade some of our Canopy GIS cover for tree species. There's an enormous variety or variation in the amount of phosphorus in leaves from various tree species. I don't remember them offhand, but I've seen variation of perhaps 3 times the concentration in some leaves compared to others, which obviously can make a difference. So lastly, once again, just trying to put all this in context, this is a graphic of about 1,000 water quality samples collected during the summer from the west branch of the DuPage River, but it's the same in all of the other basins. And what you have here on the left-hand side of the graph is the data for sites that are not influenced by wastewater output. And then on the right-hand side, you have the box and whisker showing the sites influenced by wastewater. So these box and whiskers simply, they break the data down into quartiles. So I want you to look at the upper whisker on these plots, which is here for phosphorus. These little icons here just represent outliers. And then you can see that that's about 0.5 or so. And then up here on the upper end of the sites influenced by wastewater, we're looking at about 3.5 milligrams per liter of phosphorus in the water column. Once again, this just goes to influence that it's hard to see that stormwater is a contributing the bulk of in any way of this issue. That clearly phosphorus is coming mainly from our wastewater treatment facilities. But so is it possible that advances would still need to be done on stormwater? That is not probably what the nutrient implementation plan is going to argue, but it does depend on what the state and the certainly the federal government can still override local plans and suggest alternative actions. The other factor that's an unknown here is we do not know what the endpoint is. The state of Illinois for river systems does not have a water quality standard. They have originally they came out with a recommendation of putting it at 0.1, which is down where you see my cursor. If that was the case, then obviously stormwater starts to look like a contributor. Our own analysis would suggest something more along the line of about 0.4, which would suggest that stormwater is already hitting that goal. And the reason for that I'm mentioning that is it just depends that those criteria about what is the safe level concentration of phosphorus in a waterway before it starts growing algae and impacting aquatic organisms, that is something that is an ongoing discussion with the state and federal government. And with that, I'll go to questions.
Okay, great. Thanks, Stephen. Great job. We do have a couple questions here in the chat box. Let me relay those on to you. Let's see. Do tree species matter in terms of amount of phosphorus coming from the leaves?
Yes, yeah, they certainly do. And I noticed in our, we treated each tree as a sort of a uniform unit. And that is not the case. There's variation among species. Certain species, as I said, I've seen a factor of 3. I know oak was the one that was the lower of 2. I can't remember what the higher one was, but yeah, there's definite data on that. And there are some papers out there. We just did not have enough information about, how those tree species were distributed in order to sort of add that piece of data to our map. But it would make it more, in other words, it'd be another way to prioritize that effective canopy cover if we had that input of the information. And that's something we may consider over the next year or two, adding to that data layer. Yeah, it certainly is the case.
Okay, very good. Thank you. Couple other questions. Is the MPCA, the Minnesota Pollution Control Agency, street sweeping tool similar to the WinSlam software? And if not, was WinSlam considered as part of data collection and the prediction of results?
Yeah, and I've used WinSlam in the past. So they're completely separate efforts. So they're not really comparable at all. The street sweeping tool deals strictly with street sweeping. The WinSlam is much more complete. It sort of deals with full spectrum pollutants and a number of BMPs. So it's a much more, how can I put it? It's a much more flexible tool. It also has a lot higher data requirements. You need very sophisticated or quite high resolution GIS inputs. And yeah, we didn't consider it for this particular study because we knew at the get-go with phosphorus, because that box and whisker plot that I showed that stormwater was unlikely to be a major contributor to the overall phosphorus balance in these basins. So this was a much more financially efficient way to proceed with this analysis than trying to plug all of that data for the whole county into Windslam.
All right, very good. Thank you. I see that I missed one here. From Jeff, it says, how does leaf litter falling on a forest floor contribute to phosphorus levels in streams?
On a forest floor was the?
Yes.
Yes. Yeah. So that's good. Yeah. And in case I didn't make it clear, we were only looking at leaf litter that was falling onto road surfaces. So what we find is, what the studies find is when leaf litter falls onto a lawn or onto a forest floor, that phosphorus is, leaches into the soil column, even the orthophosphorus, that's the dissolved fraction, and it is uptaken by other vegetation. Very little of it leaves the system. However, roadways, particularly those with curb and gutter, are very efficient at moving that phosphorus then into a river system. So we're talking here only about leaf litter that is on impervious surfaces and really road surfaces, though I guess sidewalks could also contribute if they were, if their runoff is into a street that then goes into a storm drain. But it is strictly impervious surfaces, really road surfaces that we're looking at.
All right, very good. Thanks for that clarification. Let's see, another question from Steve. What is done with the leaves after they are collected, and how do they not release phosphorus in the waterway in the location they are deposited?
It's a good question, and I'm not going to speculate about that they don't. So they're usually taken off to a facility, and I'm sure there's people better qualified to answer that question on here than me. But that is something that we'll also to look at: are we simply moving pollution around, in terms of time and landscape, as opposed to that is certainly possible. Especially if the leaves once again are placed on an impervious area that is once again rained on. If they were placed on a pervious surface, soil or something like that, then once again a lot of that phosphorus would be captured in the capillary spaces or bonded to those soil particles.
Okay, and kind of along that, that same line, just a question that I had is, is it better to collect the leaf litter and street sweep, or would it be better to mulch the leaves in the yard and just leave them in the yard?
If you're, and I asked Bill Sildig this exact question, and his answer was, both of those are good. It's just leaves it really comes down to the leaf on the road surface itself. So if you're mulching in your own yard, that seems to be very effective at keeping the phosphorus out of the system. Okay, very good. Thank you. Question from Rob: what equipment do you use to measure phosphorus? Yeah, so there's various. So all our phosphorus is done by a accredited lab, and what they do is that they essentially filter. They filter it into its either through depending on the size of the membrane and how much you want to break it down. You can then break it down into its filterable, meaning the stuff that goes through the filter, and then the material that does not go through the filter, and then you treat it with a reagent, which will then show the presence of phosphorus and allow you to grade how much of it is present. So it's a lab test. I've done it in the past, but we don't measure it in the field. It is all done at a lab. All right. There were a couple. Jan provided a little clarification. In Naperville, the leaves are taken to the Conservation Foundation to turn into compost for the fields. That's right. And then Dave Gorman also said waste management places collected leaves onto farmland. Yeah. Okay, so that would remove phosphorus from the system again. It would really, if it really would have to go onto an impervious pad that is then has some sort of straight gutter system to a waterway. So it's a pretty safe. I always hesitate to say it, but it's a pretty safe assumption that whatever we do with those leaves after this, it's less impactful than if they were just left where they were.
Okay, got it. I do. We had a private question that came in through a text. Is there any special impact when a city has all private properties deposit leaves in or near the street gutter for pickup prior to sweeping? Is there any special impact?
Well, yeah, I mean, obviously, if it rains on that leaf litter before it's picked up, then the majority of the phosphorus in that system would already be released, even if the leaves were picked up after rainfall. Really, what we're doing here is we're trying to stop those leaves from getting wet, and that effect is amplified. The data was actually kind of surprising. How much extra phosphorus was released from leaf litter if it was then, broken up further. So if it was kind of the structure, perhaps the cell wall in the leaf was destroyed by vehicles driving on it or so much, then that increased the amount of phosphorus being released even more so. But once it gets rained on, it releases that phosphorus pretty quickly. I believe our literature review mentions the times. I don't have them in my head, but it's, we're looking at 24 hours after it's rained. A lot of the phosphorus that will come out of leaves already has gone.
All right, very good. And I see one more question in the chat box here. If leaves are burned, does the smoke carry the phosphorus away? What happens?
Ooh, that is I'm going to take the fifth on that. I don't know. I'll have to ask somebody who has looked at that. I'm not sure that phosphorus certainly does survive that process. I don't know if it would be in the smoke, or I think it's more likely that it would be in the physical, or the physical remains. But yeah, I'm not going to answer that, Chris.
Okay. Very good. Very good. I think that is all the questions, unless I missed any. I'm scanning them again here real quick. I think that's it. I don't see any other texts, no other chat questions. So, Stephen, thank you very much. That was very informative. And thanks for all the work that you do with the Conservation Foundation, as well as with the DuPage River Salt Creek Workgroup. Great job answering the questions. And again, thank you very much for sharing your knowledge and experiences with us. Thank you.
Well, thank you for the invitation, and thanks for all the work you do.
All right, very good. Again, I think that's all we have. Thanks for joining us, everybody, this afternoon. We hope you have learned a few things from the webinar. Please remember, Mary Mitros will email everyone with a link to the presentation, recording of the webinar, and of course, that PDH certificate. Our next webinar is scheduled for April 14th, and we will get you more information about that webinar shortly following this program here later today. And that's it. Thank you very much. Everybody have a great day.